1, please. I don't know why it's not working. You guys start working on question 1. You're right, man. All right, not bad. Coming around me.
Find your name.
Seems the right one is not working. It's all right. You done question 1? Any one person done question 1 yet? Yeah. Anyway, let's do the first couple of questions now. Go on. Okay. I mean, the tutorials I take will be podcasted, and also the notes, the written notes, will be scanned online, right? All right. Question 1. Can you guys see the screen? No. No? I'm sorry, because I think that screen is out of order now. Unless I call the media services, they will take 1 hour to come here. I don't know. I think I'm sorry about it, but you can see the scanned version anyway. All right. The first one, is it representative or not? There are 5 parts to question 1. Right? This is not representative because not everyone not everyone's like football, right? Okay, maybe not in Manchester, maybe some other city, I guess. Number 2, is it representative or not representative? Not. It's not representative because not everyone can afford an expensive town. Okay. Number 3 is representative because the voting roll is used, right? So it is a truly representative sample. Number 4 is also not representative the reason being, not everybody has a TV, not everyone. Right, number 5 is also not representative because not everyone not everybody has a phone. I mean, not especially, well, it may not be the case in the UK, but in some countries in the world, many people don't have phones, right? So, okay, all right. So that's question 1. Question 2 is similar. Question 2, part 1, is it representative or not?
No.
No. Not representative. Because not everyone can afford an expensive luxury. Course. Right. Now part 2. Is it representative? Who's that talking? It's also not representative because Not everyone will reveal their true income, right? Number 3, is it representative? Come on guys, are you listening to me? Is it representative or not? No, not representative because the question is misleading or biased. So, if somebody asks you that a practice is unfair, then the answer you will give, yeah, it is unfair or something like that. So the question is not rightly worded, right? So it's a misleading or biased question, right? But most people will say, will kind of agree with the question that it is unfair. So the sample will be not representative. Okay. You guys okay? You do question 3, please. Question 3. Let me call the media so let's see. Guys, repeat question 3, please. Hello, I'm in G207. One of the projectors is not working. Are you guys okay with this or not? Yes? Yes. Yeah, 207. Did I say wrong? Yeah. The one from 1 to 2 is 209. Yeah. Yeah, this is. Yeah. You guys okay? Can you do question 3, please? Question 3. Make sure everybody signs the attendance sheet. There's attendance sheet coming around. Yes, sir. Anyone who hasn't signed?
That's the first number. The sample is X1, X2. Shows this number. There's a variance of the number of 0. Yeah, but it says that X1 is exactly the first and second number. So X1 and number 0, X2 and number 2.
Alright, the joint probability is just a select of the individual probabilities. So what you need to do is what you need to do is just you know the cosine distribution, right? So it's gonna be here minus 1 left times 1 times x can take one of these ones. So you need to write it down for each of the different. There are 5 different x. And then there are 5
and then change
I think it does. I think we all pretend that that's
I did what the guy said. Is it?
You just needed to select that and put it there, that was all.
Oh, with this, I need
Is
to
that
press
that one?
to
Yeah, so you press it and then press it again.
Oh, okay. Okay,
No
sorry.
worries, sorry.
Sorry to bother.
Okay.
Alright guys, have you done question 3 yet? Question 3, we have we have a population that consists of these values, which is 2, 3, 6, 8, and 11, right? So this is the population. The first part is we want to find the expectation of x or x1. So because these are all equally likely, right? So the expectation is using the formula I mentioned last week. Remember, this is the formula I gave you last week, right? For a discrete random variable. So this is going to be 2 multiplied by 1 over 5. Alright, and you should work this out. I think the answer is 6, I think. Is it right? Is it the answer? The answer is 6 here. The answer is equal to 6. Right, so that's for part 2. To find the variance, you need to first find this guy here. So it's gonna be this. So it's gonna be 2 squared times 1 over 5 plus 3 squared times 1 over 5 up to 11 squared times 1 over 5. And if you work this out, you will get 234 divided by 5. So the variance is it's 10.8. Okay. Part 3 is to compute the mean and the variance of the sampling distribution of x bar, right, when you sample with replacement. So the first thing you must do is to compute the possible outcomes. So when you sample with replacement, right, from this population, what are the possible outcomes that you can have? You can have 2, 2, 2, 3, 2, 6, 2, 8, 2, 11. Right? These are 5 of the possible outcomes. Then you can have 3, 2, 3, 3, 3, 6, 3, 8, 3, 11. You can have 6, 2, 6, 3, 6, 6, 6, 8, 6, 11. You can have 8, 2, 8, 3, 8, 6, 8, 8, 8, 11. And finally you can have 11, 2, 11, 3, right? So these are the possible outcomes when you sample with replacement, right? And in order to find the sampling distribution, you need to first compute the sample mean for each of the possible outcomes, right? So that's gonna be as follows. So you compute the sample for this one is 2, 2.5, 4, 5, 6.5, 2.5, 3, 4.5, 5.5, 7, 4, 4.5, 6, 7, 8.5, 5, 5.5, 7, 8, 9.5, 6.5, 7, 8.5, 9.5, and 11. Alright, you see what I have done? I have listed the possible outcomes and the corresponding values for x bar. X bar is the average of the two numbers, right? Right, now using this you can figure out the probability distribution of x bar, right? So let me get a new page. Let me move this up, right? Okay, now what I'm going to do is I'm going to draw a table. I'm going to draw a table with the first column giving the values for x bar, the second column giving the values for the probabilities. Right? Now, if you look at this one more time, you can see the possible values x bar can take, right? And they're going to be as follows. It's going to be 2 is a possible value, 2.5, 3, 4, 4.5, 5, 5.5, 6, 6.5, 7, 8, 8.5, 9.5, and 11. So these are the possible values that x bar can take. Now the corresponding probabilities. Alright, for x bar equal to 2, if you look at this, how many of the pairs have x bar equal to 2? 1, right? So the corresponding probability is 1 over 25. 25 is the total number of pairs, right? And for this, there are 2. There are 2 pairs with x bar equal to 2, right? For this, so let me complete this table. There are 4 pairs with x bar equal to 7. 8, you have 1 pair. 8.5, you have 2. 9, you have 2. And finally 11, there is 1 pair only. Now, having done this table, right now we can compute x bar, the expectation and the variance of x bar, right? So the expectation of x bar is simply the formula that I gave you last week. Is simply 2 multiplied by 1 over 25 plus 2.5 multiplied by 2 over 25 up to 11 multiplied by 1 over 25. And if you work this out, it is equal to 6 also, right? And to find the variance, you need to find this guy here, right? So that's gonna be this, and this is equal to 41.4, and therefore the variance of x bar is 41.4 minus 36, which is 5.4. All right, that completes question 3. Is this clear or not? Yes, any questions? Can you do the next one, please? Question 4, which is a continuation. Question 3. Yeah. Because there are 25 outcomes, each has equal probability. Are you sure? There are, how many outcomes are there here, sir? How many outcomes you have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it should be 25. There are 25 outcomes in total. Each has equal probability. How did you get 24? Let me check. So it's 1, 2, 3, 4. Oh yeah. Yeah, you're right. This should be 2. Sorry. Yeah, my apologies. This should be a 6.5. Should be a 2. Thank you for. Yeah, 6.5. There are two pairs with x by 10. X by 6.5. Sorry for that. Thank you. All right. Can you do question 4, please? Has everybody signed that on the sheet? Where's that on the sheet? Anyone? Anyone who hasn't signed? Yeah. Okay. Thank you. Where are the? Okay. All right. The only difference with question 4 is that you are doing it without replacement, right? So the possible outcomes are gonna be like this: 2 3, 2 4, 2 8, 2 11. Sorry, there's no 2 4, 2 6. See? 3 6, 3 8, 3 11, 6 8, 6 11. Right, and finally 8 11. So these are the possible outcomes. You can also have the elements like 3 2, 3 2, 6 2, 8 2, 11 2, but you get the same outcome. The answer will be the same if you consider the outcomes by reversing the pairs. You know, here I haven't reversed 2 3. I kept it as 2 3, but not 3 2. But if you do that, you will still get the same answer, right? I'm just doing it for simplicity, right? Now the averages. The average for 2.3 is. Hope I know how to sum things. 211 is 6.5, 4.5, 5.5, 7, 7, 8.5, 9.5. Okay, and then you draw the table with 2 columns. Okay, the possible values for x bar are 2.5, 4, 4.5, 5, 6.5, 7, 8.5, 9.5. Alright, these are the possible values. The corresponding probabilities are like this. For this is 1 over 10. There are 10 outcomes, yeah? Only one of them has 2.5 x bar equals to. There are 2 outcomes with x bar equal to 7, 1 outcome with x bar equal to 8.5, and 1 outcome with x bar equal to 9.5. So this is the probability distribution of x bar. So to find the expectation, you just simply use the formula that I gave you guys. So it's going to be 2.5 multiplied by right, and if you compute this, you will get the answer 6, right? And to find the variance, you need to compute this, right? Okay, and if you do that, you will get the following. You will get 2.5 squared times and this is 40.05. Alright, this is the expectation of x bar squared. Therefore the variance of x bar is the difference, 40.05 minus 6 squared, which is 36, and this is 4.05. Right? So what we see from this is that for sampling without replacement, the variance is 4.05. The sampling with replacement, we saw in question 3 that the variance was 5.4. So what you conclude from this is that sampling without replacement sampling without replacement is more efficient in this case because it produces smaller variance. Remember, variance is a measure of variability. The smaller the variance, the better the efficiency. So 4.05 is smaller than 5.4. So sampling without replacement is more efficient in this case, right? All right, can you do question next one? What's that? Question 5. Yeah, that's what I said. You can.
So you scared? No. It might just work. You don't want it might work either. It wasn't the update, it was the fact that the server was down. You can use the log on the we've done it.
The joint probability is just the product of the Poisson probability over the 5 observations. You have x1, x5, right? What you do is you compute the Poisson probability. You know the probability, the PMF of the Poisson. Yeah, so you compute that for each of them on the 5, and then you take the product.
This is working good. I think it's the update. I think it's so. Does it say there's an update? When?
If you want to hand in quiz 2, can you please? You can do so now. If you have completed quiz 2 and you want to hand it in, you can do so now. You have done. Thank you, ma'am. Anybody else who wants to hand in quiz 2? You done?
Yeah.
Thank you.
Yeah, something like that. But if I don't even want to do it with that something, yeah.
Alright, question 5. The population consists of these numbers 3, 7. The first part is to find the population mean, which is trivial. Right, so to find the expectation of x bar is the population mean. We take the sum of, this is the formula I gave you guys. Each of these numbers has equal probability, so the mean will be 3 times 1 over 5 and this is equal to what? This if you work this out, this will be equal to 9. That's part 1. Part 2, we are drawing 3 numbers without replacement from this population. So the first thing you need to work out is the possible outcomes, right? So the outcomes, three, 7, 9, 3, 7, 11, 3, 7, 15, 3, 9, 11, 3, 9, 15, 3, 11, 15, 7, 7, 9, 11, 7, 9, 15, 7, 11, 15, and finally 9, 11, 15. Right, so these are the possible outcomes, and for each of these outcomes you need to compute the sample mean, that is the average. Okay, so the first one, okay, let me use color. The first one is 19 by 3, 21 by 3, 25 by 3, 23 by 3, 27 by 3, 29 by 3, 27 by 3, 31 by 3, 33 by 3, and finally 35 by 3. So these are the values of x bar for each of the outcomes. Right now you know what to do, right? You know how to compute x bar, right? The expectation and the variance. So because each of these averages is different, so the corresponding probability is what? 1 over 10, right? There are 10 outcomes, right? So it's going to be 19 by 3 times 1 over 10, 21 by 3 times 1 over 10, up to 35 by 3, 1 over 10. Right? And if you work this out, you will get the answer equal to 9. Right? And the expectation of x bar squared, right, is the same, right? You just square the numbers. Right, and if you do this, you will get the answer 83.667. Right, and finally the variance of x bar is just the difference. So it's 83.667 minus 9 squared, which is 81. So you will get 2.667. That's the variance, right? Okay, guys. I think the other two parts of question 5, the only difference is that instead of computing the sample mean, you consider the sample median. I'm sure we know how to compute the median by now, right? So for each of the 10 pairs, you need to compute not the mean but the median. I'm sure you know how to do it. Yeah. All right, guys. So I will. If you haven't done quiz 2, could you please hand it to me today or tomorrow or early on Monday, because I want to have time to mark all the papers before the lecture. Right? Okay. Okay, guys. Thank you. Have a good weekend, guys. Yeah. Hello.
For the homework for this one, are you the different substitutions than the one you gave us here? Is that alright?
Yeah, that's fine. As long as you've done it correctly.
Yeah.
Yeah, right. How is it?
I have a question. This question is why cannot because we have
Yeah, you can have 2, 3, 2. I mean, you can have 2, 3, 2, 6, 2, all the pairs. This is without replacement. Which one is it? Yeah, you can have the reverse pair also.
Does it make a difference if you include the reverse pair?
well,
So the mean
The
effect.
answer will be the same.
yeah.
The answer will be the same if you use the reverse pair.
So
Yeah, thank you, sir.
the
But this is shorter because you don't need to consider the reverse pairs. You get the same answer. You know what I'm saying?
so I did it correctly.
Yeah. Yeah. Did it correctly. Thank you. Okay. You, ma'am, okay, you have some questions or what? You have, yeah.
Yeah,
You have,
signed, I just enrolled a course in this week, so I haven't got a chance to take any lecture. So I
had you got my lecture notes? Did you got my lecture notes?
Nothing.
No? Just wait then, I'll give it to you now.
Oh, that's nice.
I'll give it to you now.
Thank you.
Hello, sir.
It's not. I just wanted to ask a quick question.
Yeah.
With this one, I ended up with this as a result. Just wondering if that's correct or not.
I can't tell you, so I'm sorry, I cannot tell you.
Okay,
I cannot tell you if it's
Alright.
correct or not.
Not correct, but have I used the right method? Because changing that to, because that can be.
Yeah, your method seems okay, yeah. Seems okay.
Okay.
Just a minute, I will give you my notes. Just a minute.
Thank you. I just want to ask, if this kind of the proof process should be remembered, or I just need to know the result.
Final, you mean for the final exam?
Yeah.
For the final exam, you should go to the course website. Can you go back to the website? Go up. No, it's here.
Oh, yeah.
It's here. Click here. These are the formulas you need to know for the final exam.
I need to remember.
Yeah, you need to remember. And these are the notes, ma'am. I want to give you. Now, this is the coursework. This is due on the 29th of April. And these are.
I've already downloaded the R.
Yeah. This is the distribution. And this is quiz 1. Have you done quiz 1 or not yet?
Not yet.
I think you missed it then. This is the lecture notes. This is the lecture notes for the whole course.
Lecture notes.
For the-
Similar to textbook. Like textbook.
Yeah, similar to textbook. You have a question? Which part? You mean this one? The joint probability, yeah, the joint probability is just the product of the probabilities. Like, say, can I write here? You just compute the you compute this for each value of x1. This is the Poisson probability for x1.